Hey, so today I'm going to be doing some copper spinning. I've gotten a few comments on the other few videos I did that I never showed how I'm doing any of this. I just kind of do the aftermath and the results. I'm not really good at this, but there are a number of videos online of really professional copper spinners that do amazing things, and most of it stuff's ornamental, and they're really good at what they do and are able to demonstrate their craft. I'm still just figuring this out, and a lot of the stuff that I'm doing today I just either recently figured out or I'm gonna have to figure it out on the fly as I go, because I kind of have a weird project. So what I'm working with today is copper. It's exclusively what I spin with. I have a Nova lathe here. It's a wood lathe. Comet 2 MIDI lathe. I have a little Nova chuck here. It's a 4-jaw chuck. I have a couple of different jaws for this one here. This is about the smallest one. This is kind of like the for spinning pencils and what have you. It goes pretty small because I'm working with 3/8, 5/16. That's mostly it here today. I just thought I would show you. This is an ejector. Or at least the venturi part of the ejector right here. It's kind of an elongated venturi. So we have a piece of 1/2-inch water pipe, 5/8 inch outside diameter, and you can see it's restricted here to, I think it's about 3/8 of an inch inside diameter, and then for about that length right there, and then it elongates and diverges back out. This was for a project I had for a 2-phase thermosiphon. This was going to be used in conjunction with a small primary motive nozzle. This is kind of an experimental one. You see that I made it and then I brazed it into a swaged piece of 3/8 tubing. It's supposed to be inserted in here to shoot refrigerant down through the center. And in this case it was alcohol, methanol specifically, and it was a vapor ejector. If you're not familiar with ejectors, you can do a little quick search. I have a video that talks about them. I did a bunch of work with refrigeration ejectors a few years ago. I had some success, but I mean, there were so many other deficiencies in my system, it really didn't matter. So this was kind of a neat piece to make. It was difficult to do too because of the length. Whenever you're working that far away from the center, it'll tend to want to wobble, because what I have to do is apply some pressure with a metal tool. This is my tool, my only tool, my little round nose tool that I made. It's polished pretty good, but it's still got a lot of grooves and scratches and stuff in it. Working that far away, so what I end up doing is working with a live center on the other side to support it. And the biggest issue there is whenever you're deforming the copper tubing, it can tend to elongate or shorten, which puts a lot of pressure, and then it ends up getting loose over here, and then it starts to walk around and stuff. So you constantly have to move this back and forth, and I'll figure out better ways to do this. But today I'm mostly going to be working rather close to the chuck and making this next ejector in several pieces that are going to eventually be brazed together. I made some test pieces the other night to just kind of figure out the methods and the tooling, the techniques that I'm going to have to use here, and then eventually they're all going to be assembled together to make a longer ejector. So that ejector is comprised of several pieces. These are rather small. I'm going from a piece of 5/16 OD refrigeration tubing. I have to constrict it down to an inside diameter of about 70 thousandths or so to fit this piece of 26 thousandths ID capillary tube in there. And that's going to be my primary motive nozzle. That's going to be inserted into the basically the mixing, converging section of my ejector. That gets inserted in there, and it's actually supposed to extend the whole way up to the throat, which is right here, and that throat is the mixing area, or passes into a this is a piece of 1/8 inch OD, I think about 64,000 ID tubing, and then from there it will go to a diverging piece. This one was a failure here. This one broke, so I didn't get small enough there. And this will have to be reduced to 1/8 inch ID on the inside there. and then it will diverge back out, and this will all have to be brazed together, and it has to be done in a way that everything is perfectly lined up. Everything is concentric and parallel, has that common axis right down the center, because I want this piece right here to inject directly into the center of this. And in order to accomplish that, this piece of 3/8 tubing right here, 3/8 tubing by itself will not accept a piece of 5/16. It's very close, and you can really easily swage it with a swaging tool, or like an adapter with a flaring tool. However, it's not going to be perfectly concentric, and it's going to get a little bit askew. So it's not going to be very long. So once I stuck that piece of 5/16 in there, it might be a little bit askew, so it's not going to inject directly into my piece of 064 tubing right there. So I'm going to swage it instead with the lathe. I found a pretty easy way to do that here the other night, just by jamming a piece of 5/16 into the spinning copper tubing. Works rather well. Also, I have to do a little bit of work grinding my piece of capillary tubing down, so kind of give it a point, but maintain that orifice rather well. I also take a Dremel tool with a little little ball, what do you call it? Anyway, little ball and grinding stone there, and kind of grind this into a concave shape, such that once these are lined up, it will inject in there rather well. But I have to have a little bit of distance there, because the purpose is that I'll be able to create a little bit of suction through this hole on the side. I'll have a piece of tubing that's brazed into that hole. It's going to be saddled a little bit. It's going to be saddled onto this and brazed rather delicately, such that whenever that primary fluid gets injected into this mixing region here, it comes out of the primary nozzle at a really high velocity and a low pressure. And that low pressure creates the suction that causes the suction gas from an evaporator to be mixed with this fluid passing through the mixing region, which is going to be 3/4 to an inch long. And it's going to give up some of that kinetic energy to the suction gas. And whenever it diverges and the cross-sectional area increases on the outlet of the ejector, the velocity drops and the pressure rises to a higher pressure than the suction gas, but to a lower pressure than the original high-pressure motive fluid. So, like I said, I'm going to be doing that with this. I think this is a 1/2 inch tool steel, and it was just shaped to kind of that flat duckbill region there, and then a round. And this is just kind of a general use tool. I was going to make more tools. I made a really crude wooden handle for it. So this is as far as I've ever really gotten with the tooling. This is my stand right here. I can move this around as need be. Sometimes I want to get a little bit closer to where I'm working, but at the same time I have some spinning objects that are here in the way, so I have to be careful about that. This had a little wobble in it that needs to be improved. Lubrication I do with, currently, I do it with Castile soap. It tends to stick pretty well, doesn't fly off. I've used paste wax in the past, and when it gets warm it starts to just fly off and make a mess everywhere. So I have a feeling there's probably better lubricants than this. I'm going to use a little bit of a beeswax candle today to see how that works for me. And I'm also going to be using a number of different collets. So I have a series of collets I've purchased for this lathe when I first bought it, and those get inserted into the headstock right behind this chuck right here, and get drawn in through with a piece of all thread that extends through and is tightened on the back side. And that allows me to use forms like this piece of drill rod that's 1/8 inch that can extend out through my chuck, and whenever I'm spinning that copper I can spin it down onto this surface, such that whenever I remove the piece I have that nice 1/8 inch ID on the inside of the piece. So I'll do that with different diameters, and I have different lengths that are cut. And then I also have different forms, like this little piece of 5/16 steel here with a hole drilled in it. That was from another project right there. But sometimes I'll actually use this as a form to help to support the pieces that I'm working on while they're inside the chuck, because you start crushing that copper with this chuck. Although 3/8 works fairly well in here, and it supports it pretty well, other diameters you really have to crank down on them in order to support them. You end up kind of deforming them a little bit. So I want to try to retain this diameter as well as I can, so leave the 5/16 form in there, and it'll also hold on to it a lot better, and it won't get so loose, because periodically I have to heat the copper up and anneal it, because it does work harden as you're working into there. So like I said, I'm not that skilled with this, and the operating speeds I work at are just kind of whatever seems to be appropriate. The lubricant I use is just kind of what I had laying around, and the techniques that I use are just kind of stuff that I've had to figure out. So I can't do any editing on this video, so I'm just going to kind of pause and continue. So there are going to be mistakes that are made along the way, and I'll have to back up and restart at certain points. So this is just what it's like for me to do this kind of work, but enjoy. Okay, so I got a piece of 3/8 tubing right here, all chucked up. I'm going to use my little deburring tool right here, and just put her in there and clean up the edge a little bit. It'll work. I'm going to use a propane torch for annealing, so it's going to take a little bit longer. Starting to get that color change. There's no need to work this hot, but there's no need to really cool it down, as far as I know, really, either. So this is a piece of 5/16 that I have mounted in this chuck. It's a solid chuck. I have it ground down at the end a little bit to make it so it'll go in there a little bit easier. It's also ground down on 3 sides, just so it kind of works its way in there. I don't know really the logic behind that, but it seems to make sense to me. I'm going to take a little bit of soap. Once it hits that hot copper, whether from the torch or from the friction of this thing entering in there, it's gonna thin it up a little bit, and it should lubricate. Probably not really necessary. I'm gonna turn up the speed a little bit so I have a little more kinetic energy stored in that chuck there, and I'm going to lock down, turn her up, feed it in slowly. It's actually a lot better than the first few times I did it. I was using some older copper tubing that had been worked a lot, so this was still pretty soft. So this sucker went right in there. Didn't have any problems at all. Initially I ran out of thread. I don't have a lot of range on this tailstock here, so I just started to shift it in so I could rethread it, and it was just feeding right in. So this should accept a piece of 5/16 pretty well at this point. This piece has a bit of an edge on it. So that ought to work pretty well. So we're going to pull it out and move on to the next spot. Alright, so I had to pause a little bit and make another piece. Took a little piece of 5/16 like this, and I drilled a pretty large hole through it. And that is actually inside the copper tubing, and it's helping to support the wall of the tubing. There's a large hole drilled because I want my 1/8 inch right there to pass the whole way through that chunk of metal right there, that support plug, and goes into the collet, which is back here in the headstock. So that's that 1/8 inch is nice and tight between the headstock and the tailstock right there. So I'm going to attempt to spin this piece of